Welcome back. While line plots show trends over a continuous range, scatter plots are ideal for visualizing the relationship, correlation, and distribution between two different variables. In this lecture, we switch from plt.plot to the dedicated function for point data, plt.scatter. 1. Preparing data for scatter plot. We generate 50 random data points for x and y. Crucially, the scatter plot is powerful because it allows the size and color of each individual point to be controlled by two additional independent variables. We create colors and size arrays for this purpose. 2. Generating the basic scatter plot. The syntax for plt.scatter is similar to plt.plot. X data first, then Y data. Unlike the line plot, the scatter function draws unconnected markers at each X, Y coordinate. 3. Controlling point size and color. To use our auxiliary variables, we pass the size array to the S argument, making each marker proportional to its corresponding size value. We pass the colors array to the Seeth argument, allowing the color of each point to map to its color value according to a defined color map, such as Voridus. We also add transparency using alpha to better visualize overlapping data points. This creates a powerful four-dimensional visualization: X, Y, size, and color. To summarize, scatter plots are excellent for exploring multidimensional data visually. Our next lecture 37.07, bar graph. See you there.